Hello everyone. So today we are going to see what is the difference between HashSet and TreeSet in Java. So let's go to the introduction first. So we'll go through one real life example. So imagine you are organizing a list of your favorite book, but you don't want duplicate. Okay. Naturally, you would make a collection that holds only unique item. In the Java, two popular classes help us to do this. One is HashSet and another is TreeSet. While both store the unique element, but they behave very differently under the hood. So knowing when to use which can make you code faster, cleaner, and more efficient. So in this article, we'll explore the key differences between HashSet and TreeSet, and we'll break them down with the example and highlight the best practices every Java developer should know. So let's go to the core concept. What is HashSet? So HashSet is a part of Java collection framework and it is implemented using a hash map internally. So it stores the element in the unsorted way and ensure that no duplicates are allowed. So we need to if we are adding the element into the hash set, the elements are not sorted in a particular order. That then another is performance. So HashSet offers a constant time, that is big of 1 performance for basic operation like add, remove, and contain. Suppose you want to search any element, that means contain. Then null element, it will allow only one null element. So you would use the HashSet when order doesn't matter. That is like in the sorting order if it is doesn't matter and you just want fast lookup and insertion, like keeping a track of unique username and or we can say product IDs. Let's go to the another, that is tree set. So tree set is based on the tree map and it will store the element in the sorted, that is nothing but the ascending order by default. So it maintains the elements in the natural order, for example number in the increasing order or the string in the alphabetical order. So the order of element will be always sorted. Performance will be operation like add, remove, and contain take a big of log n because they use the balanced binary search tree, which is nothing but a red black tree. It will this tree set don't allow the null. If we try to add this, we'll get a null pointer exception. So you'd use the tree set when you want to maintain a sorted data, like displaying the name alphabetically or sorting the scores dynamically. So let's see an example of hash set. We'll create a hash set. We'll add the city names. We'll try to add a duplicate, but it will allow only unique values. And if we try to print it, then we'll see whether there is any order maintained or not. So let us create a hash set. We'll add the element, then we'll print it, and let's see, run as a Java application. So if we see, let me maximize this. Yeah, so the cities, let me copy this and paste here. So the output will be looking like this, cities in the hash set. So if you see, there is no sorted order, like alphabetical order in this. We are just adding randomly and randomly we are getting the output. Okay. Also, if we can see, Mumbai is added twice, but it is only once here. And here also we are checking whether this map is containing the city Delhi. Then we'll be printing this. As it is containing Delhi, it will be printed. So this is a example. HashSet doesn't guarantee any particular order, as we have seen from the output. Even though we added Delhi first, it might not appear first when printed. So we have seen a duplicate like Mumbai are automatically ignored. So this make HashSet lightning fast for lookups and ideal when order doesn't matter. Then in that case we can use the HashSet. Now let's go to the tree set here. Now we'll first see the same example. What I will do is tree set. Now there was no sorted order. If you can see, this was the output. Now if I try to run this application and if I get the output, this will be the output. Now if you see the output inside that, we'll be having this in the alphabetical order: Chennai, Delhi, Kolkata, Mumbai. Because we are using the tree set, it will internally use the red back tree, which will be sorting in the natural sorting order. That's why we are getting it in a sorted manner. So this is the difference, main difference between hash set and tree set. Tree set construct a new empty tree set sorted according to the natural sorting order of the elements. Let's go through the another example of the numbers. If I go here and paste here, so we'll be adding these numbers and we try to print this. What should be the output? First 20, then 40, then 50, then 80. It will be in the natural sorting order. Now if I try to run this as a Java application, okay, save and launch. Here we go. This is 20, 40, 50, 80. And there are, let's see, if you want to print the first element in the tree set, then we can directly this score dot first. Then if you want to print the last element, we can print like this. So in the case of integer, the first one will be the lowest score and the last one will be the highest score. Then yeah, let's go to the explanation. Here the tree set automatically stores the element in the sorted order. That is nothing but ascending, even though we added them randomly. If you need to maintain a sorting or easily fetches the smallest or largest element, tree set is perfect. What are the best practices? We need to choose hash set for the speed. If order doesn't matter and you need a fast operation, we can prefer a hash set. When we can use a tree set, when the sorting is essential. So if you were used to your use needs a natural or custom ordering via comparator, we can go for tree set. While working with the tree set, we need to make sure that we should avoid the null. If we are adding a null, then it will cause a null pointer exception. So while working with the hash set, we should not rely on the order. The order may changes depending on the hash code and internal tree resizing. Avoid using it where order matter. Consider link hash set for predictable iteration order. So if we need an insertion order to be maintained and the element should be unique, then we can go for the link hash set. So we can go to the conclusion, both hash set and tree set help us to store a unique element, but they serve the different purpose. Hash set, we can use hash set for the speed and efficiency when order doesn't matter, while on the other hand, use a tree set for the sorted data and navigation. So I'll add this blog link in the description. You can go through the difference. So if you like this video, you can hit like button and subscribe to our channel.